Hello and welcome everyone. In this video, we are going to be discussing about limits and its indeterminate forms. So before starting this topic is very important for our advanced as well as for mains. Okay. So before diving deeper into it, first let us have a very clear concept about what exactly is limit. What does it mean in literal sense? So limits, an introduction. So limits is basically in literal sense, if we want to say, it means approaching something. Okay, so whenever we use this term limit x tends to 1 or limit x arrow 1, that is, so whenever we write this term such as x tends to 1, this literally means that when the value of x is tending towards 1, when the value of x is approaching 1. Now x is a variable, so it can have many values. Now depending on the value of x, the value of the function, like for example here I have taken a function x square minus 1 divided by x minus 1. Now the limit concept of limit says that if x is closing or it is approaching to 1, then what will be the value of this function? So it's very easy to work out. Whenever we have been given a question and it is said that which limit we have to find. In this case, let us take x is tending towards 1. So if we put the value here, we can easily see that it is coming 0 by 0. Now in general, the denominator must not be 0. If it is 0, we say that the limit is not defined. But such cases where we have both the numerator as well as the denominator 0, we say that these are our indeterminate forms. Here we have continued with the example. We have taken many values 0.5, 0.9. As you can see that we are actually approaching closer to 1. But we see that as we are approaching towards 1, we are actually getting closer to 2. The value is actually getting closer to 2. So that creates a confusion that when x is equal to 1, we know that it is indeterminate. That means the value should be undetermined. Because that is what the name says. Indeterminate forms means undetermined. But when I am just putting the values in random order and I am trying to approach x in terms of the values, we are seeing that as I am approaching towards 0.999, that is towards 1, I have not taken exactly 1, I can see that the value of this function is closer to 2. Okay. So that kind of gives us a confusion that whether or not this particular function has a limit or not. So yes, mathematically we were not able to show that the limit as of now with the concept we have. Mathematically we are not able to show that the answer will be 2. We want to say because when we are putting the values we can clearly see that it is giving us the value 2. Okay, but we cannot because we cannot show it. So it is a special way, or limit is a special way of saying that whatever happens, ignoring whatever happens when we get exactly at the point given in the question, as we get closer and closer to the answer and closer to 2. We don't know exactly at 1 what will happen, but as we get closer and closer to the answer gets closer to 2. So that is, we can say that the limit is 1. Sorry, the limit is 2. Now, here is the thing. Now, as we can see that when we were taking the value, we saw that we were taking only the positive side. Okay. But, yes, this creates a confusion. It is just like running up a hill. To find the path is not there. So suppose if I am running up a hill and I am climbing, but if we just check from one side, we will not know what is the other side remaining. So that is why we should check both sides to be sure whether what it should be. So with that point in mind, let us check from the other side. If you remember, we had taken the function, we had taken this function and all the values of x were taken as positive. We did not take the other side of x, that is the negative side. So let us further dive and check what will the value of this function be if we take x from the negative side. Because with this result we are going to have the limit as 2. But is it exactly 2? So here I have taken from the other side, that is when it is increasing from 1. So again, as you can see, even though we are taking the higher values from 1, we are still getting the values which are closer to 2. So that gives us a confirmation that from both the sides the limit is approaching to the point 2. So this is where we can be sure that yes, limits from both the side is 2 and hence the function for this limit is also 2. Now mind you that this is an indeterminate form. So later on in this chapter we will learn a very important law or important rule to solve this type of functions, which is indeterminate form. But as of now, let us move to the next slide. So in the previous example, we saw that even from the other side, we are getting the same answer. On both the sides, it was approaching 2. But what will happen if the answer does not match from both the sides? In that case, we just simply say that the limit does not exist at A. Like for this example, if I am considering the point A, I am considering the left hand side and I am considering the right hand side. Now when I was considering the left hand side, my value for the function was approaching 3.8, whereas from the right hand side it is approaching 1.3. Now the value or the gap between 3.8 and 1.3 is very huge. So we will say that the limits does not exist. Now till now we were only discussing about the values where we have the exact values of or a defined value. Now we will approach towards infinity. Now infinity is a very special concept. We know that we cannot reach it, but we can work out some value so that at least the function can give us an idea where is this approaching. So here we have taken a very interesting example, that is 1 by infinity. We will be using this idea a lot in this chapter. So 1 by infinity, we know it is 0. But how do we know that it is 0? Because infinity, we cannot define infinity. But when we say 1 by infinity, why does it becomes the value 0? Well, the concept again comes from limit. So as you can see here again, I have taken the graphical approach. I have increased the value of x. I had started with 1 and as you can see, I am increasing the value of x. As I am increasing the value of x, the reciprocal of x is gradually decreasing. And with the graph, you can see that it never goes to 0 or never is exactly 0, but it is actually approaching towards 0. And that is why we say that whenever a limit tends to infinity, 1 by x tends to 0. This gives us a very important result that whenever 1 by x will be tending towards, whenever x is tending towards infinity, 1 by x is tending towards 0. So this in mathematical sense it means that we know that whenever x is equal to infinity, we can say that as x is getting bigger and bigger, the answer of the reciprocal will be getting closer and closer to 0. That is the idea behind this. Now, next topic. Now, with the idea in mind of limits, how to find or how to evaluate the limits. The first process is pretty simple. This is called substitution method. In this, we just put the value which is given, like in this case, It is given that x is tending towards 10 and this is the function. So we just straight away put the value of x here as 10 and we get the value. So when x is approaching to 10, x by 2 is approaching to 5. But in this case, as we had seen we had taken this example previously also, in this case we are not getting any definite value. This is an undetermined form. So for undetermined form, we cannot use the same process. But later on we have a process, as I had told you before, we can go into further. So the next process is factorizing. Now, as you can see, I had told before also, whenever the numerator is 0, it's fine. Until and unless the denominator is not 0, we can continue. But whenever the denominator becomes 0, we need to sort it out. And the best way to sort it out is by factorization method. So, taking this example in mind, you can see that when I put x equal to 1, in this function, it becomes 0. So that is why instead of writing just 1, we have taken or we have factorized x square minus 1 into its factors. As you can see, when x is tending towards, this will get cancelled and we are left with x plus 1. So now we can substitute x equal to 1 to get the value 1 plus 1, 2, which again is similar to the idea which we got in the previous slides. Next. The next is conjugate. So conjugate is mainly used for surds like this, wherever we have surds or irrational elements like here, in this case root x. So the first thing which we do is we take the help of its conjugate. Now again in this case also it is becoming 0 by 0 form. So the first thing which we do is whenever we see a surd, we first take the conjugate of it and rationalize it. So once rationalized, you can clearly see that this part is getting cancelled out and the remaining portion is now actually a definite value. So now we can put the value of x equal to 4 and we will get the answer. So this process is called rationalization. So we have dealt with 3 process as of now. The first one was substitution. So the first method which should come to our mind is the substitution, that is you can just straight away put the value and get the answer. The next is factorization. We do factorization only when we see that it is giving us an undetermined form. For any of the values of x, it is giving us an undetermined form. That is when we go to factorization. The third step is rationalization or taking the conjugate. Now this process is done when we have an irrational or surd present there. Next is infinite limits and rational functions. So in this question, this is px by qx. Now we will be dealing with rational functions where we have 2 separate functions and their division is giving us another function which is a rational function. A rational function is the one that is the ratio of 2 polynomials. Now comparing the degrees of px to qx. As you can see that the degree of p is less than degree of q. Okay, so whenever this happens, whenever we can see that the degree of px is less than the degree of q, the limit is 0. But if the limit of p and q are the same, well then we divide the coefficient of the terms with the largest exponent. So in this example, as you can see that the degree of p is obviously greater than that of degree of q. Now here x cube is the largest exponent in the top, whereas 6x square is the largest exponent in the bottom. Now both are positive. So now since p is greater than degree q, the limit will be positive infinity. But if In this case, for this example, as you can see that the largest exponent on the top is minus 2x square and in the bottom it is 5x. So again, here the limit will be minus 2 by 5. Now, remember this, whenever the degree of p is greater than q, it is very easy to find the limit. Just take the limit of the highest power and the limit of the lowest power from the denominator. Whatever the coefficient will come, that will exactly give us the value. That means in this case, it is actually 1 by 6 and in this case, it is minus 2 by 5. The last method is the L'Hopital rule. L'Hopital was a French mathematician in 1600. He was the one who discovered or rather made this rule. Now throughout this video we are discussing about a form that is 0 by 0 or infinity by infinity form. Now these forms are called indeterminate forms. Now in general, a denominator or in a rational function, the denominator should never be 0. But sometimes what happens, fx as well as gx, when x tends to c, both become 0. Now in that case, we say it is undetermined or it is indeterminate form. So the easiest way to solve those sums is using the L'Hopital rule. Now L'Hopital rule has some conditions, so let us go through that. So this is the example we have taken here. As you can see, if we put x equal to 2, it is giving us 0 by 0. Now the conditions for L'Hopital rule is it should be differentiable and the limits must exist. They should be continuous, differentiable, and only when both of them are continuous as well as differentiable, then we can proceed to using L'Hopital rule. Now one thing to remember, we don't have just two types of indeterminate forms. There are actually 7 different forms of indeterminate forms, but L'Hopital rule can be used only for 0 by 0 and infinity by infinity form. For all the others, we have to convert the given function into 0 by 0 or infinity form, only then we can solve it. So let us take the previous example as our data and see how can we solve. So this was the function. So as you can see, x when tending towards 0, it is giving us 0 by 0 form. So as it is both continuous as well as differentiable, the next thing we will do is we will just differentiate it. Once differentiated, we can see that we are getting the value 5 by 4. Now this was pretty easy. This we just solved it once and we got the value. But in many sums, we can see that it will not be solved at once. So we have to continue doing this process unless and until we get a defined value. So that's it with the evaluation of limits. We will discuss the evaluation of limits with L'Hopital rule in the next video. Thank you.